Alright, so in this video we're going to practice factoring some complex quadratics, specifically the difference of squares. So difference of squares, to be really clear, if we have a quadratic that is squared, it might look like this, so x plus 3 squared, which is x plus 3 times the quantity x plus 3. So this would be x plus 3 squared. So the difference of squares, difference referring to a negative, but the difference of squares is going to be x plus 3 times the quantity x minus 3. So it's like they're squares, but actually one is positive and one is negative. So this is what's considered a difference of squares. Okay. Now, a difference of squares is pretty special. It's always in the form like a plus b times the quantity a minus b, meaning there are two terms, a and b, and we are adding those two terms, and the other we are subtracting them. Now, in difference of squares, when we multiply them, so x plus 3 and x minus 3, what happens, so I'll do this, so it's x squared plus 3x minus 9. What happens in difference of squares is that the middle term, the b term, usually goes away, actually always goes away. So positive 3x minus 3x is 0x's. So we're left with x squared, 0 times anything is 0, minus 9. So we always end up with just the ax squared term and the c term, because the difference of squares makes it so that the bx term goes away. Okay, so something that a lot of people memorize is that if you see something in the form a plus b times a minus b, it will always equal a squared minus b squared. So meaning the first term squared, in this case x times x, to be x squared, minus the last term squared, so 3 times 3, which is 9. We can also use that in the reverse. If you see something in the form a squared minus b squared, then that will always be equal to a plus b times the quantity a minus b. So this is again what's called, this is actually what the difference of squares is. Okay? Alright, so let's go ahead and do this in practice. So I see 9x squared minus 1. So we can do this by factoring if we want. If we did this by factoring, we would have to add in the bx term, so it would be 9x squared plus 0x minus 1. We would do the box method. First term, first box. Last term, last box. A, which is 9, times c, which is 1, goes in the t-chart. Write down the factors of 9. And we look for the two things that combine to give us 0. If one is positive and one is negative. So positive 3x, negative 3x, and then we factor. These both share a 3x. These are both divisible by just a 1. Divisible by 3x. And divisible by a negative 1. So this is 3x plus 1 times the quantity 3x minus 1. Okay, however, we don't have to do it that way. Instead, what we can do is use the difference of squares method. So I see it's 9x squared minus 1. And so what I notice is 9x squared is actually 3x times 3x. Right, and then I know that to get 1, it's actually 1 times 1 is negative 1. And so 3x plus 1 and 3x minus 1. That only works if it's a difference of squares, okay? So here's another quick example. So what if we looked at 16x squared minus 25? So when I look at this, I notice right off the back that 16 is 4 times 4, and 25 is 5 times 5. So this one will be 4x times 4x to give me 16x squared. This one will be 5 times 5. And to make it so that that middle term goes away, one's positive and one's negative. Okay. So to quickly show you a non-example, if I had 16x squared minus 3, 16 is 4x times 4x, but 3 is not something times itself. Like I can't do like 3 times 1 and make one of them positive and one of them negative. Like that's not going to work because that won't get rid of the middle term. This number has to be the same. Instead, if this was something like 9, then I could do 3 times 3 and that would be okay. All right, so let's look back over question number 5. Some of you saw this yesterday, which is totally fine. I will rewrite it slightly. X squared minus c equals x plus 6 times the quantity x minus 6. So this is asking what value of c would make the equation true. So yes, well, in other work we learned that you could multiply these together to find out what the value of c would be. Another way of doing that is by noticing that this is actually a difference of squares, a plus b times a minus b. And so we know it's going to be a squared minus b squared. So b squared would be 6 times 6, which is 36. And so this value is going to be 36, which is d. So that's a faster way of doing that problem.